Number 6, supernovae explosions. A star dies after running out of fuel, and it explodes, releasing more power in seconds than our sun will produce in its entire lifetime. That energy and radiation of shockwave travels outward in every direction at the speed of light. If it was anywhere within 100 light years, we probably see asteroids and meteors flying in our solar system. And if it was within 25 light years of Earth, it would very likely cause human extinction because the radiation strips the ozone layer, the thin shield protecting every living thing from the sun's ultraviolet radiation. And with no ozone, ultraviolet radiation floods the surface. It's raining acid, plants and animals die, the food chain collapses, and Earth becomes uninhabitable. Researchers at Kiel University publish findings that it is very likely nearby supernova explosions have caused at least two mass extinction events in Earth's history. The Ordovician extinction 440 million years ago, which killed 60% of all marine species, and the Devonian extinction 370 million years ago that wiped out about 70% of all species on the planet. Both events match the calculated rate and timing of nearby supernova. The good news is there are only two nearby stars capable of going supernova within the next million years. Consider us lucky. Number 5, rogue black holes and tidal disruption events. You probably picture a black hole sitting at the center of a galaxy, pulling everything nearby into it. But in August 2024, scientists at the Zwicky Transient Facility detected a star being torn apart 2,600 light years away. Astronomers call this a tidal disruption event, an extremely rare phenomenon where a black hole rips apart a passing star that is floating in the outer regions of its galaxy. A team from UC Berkeley and the Hebrew University of Jerusalem confirmed it using premier radio telescopes, publishing in the astrophysical journal Letters. What they found was the fastest evolving radio emission ever recorded from a black hole consuming a star. Two separate radio flares that were months apart, meaning after tearing apart the star, it didn't immediately disperse matter and energy, it released it in random intervals. What's terrifying is the implications. If supermassive black holes can wander outside galactic centers, then the universe contains likely billions of these rogue destroyers. They are invisible and they emit no light until they eat something. So if a rogue black hole drifted into our path, we wouldn't even know until it is too late. Number 4, interstellar cold clouds. The sun moves through the galaxy at over 500,000 miles per hour, taking every planet with it. Surrounding the entire solar system is a protective bubble called the heliosphere. Think of it as the solar system's atmosphere. It is generated by the sun's solar wind, a constant stream of charged particles that pushes outward in every direction, holding back the harsher radiation of deep space. In June 2024, astrophysicists Merav Ofer and Avi Loeb published a paper in Nature Astronomy presenting something unsettling. 2 to 3 million years ago, the solar system passed through a dense, cold interstellar cloud, a region of space with hydrogen density thousands of times greater than the surrounding medium. The cloud's pressure compressed the heliosphere so severely that it shrank to less than a quarter of Earth's orbital distances. Earth was outside the force field entirely, exposed directly to galactic cosmic rays at intensities 10 times higher than today. The geological evidence confirms it. Radioactive isotopes not produced on Earth were found in ocean floor sediments, Antarctic ice cores, and on the Moon, all dating to that same period 2 to 3 million years ago. Without the heliosphere's protection, galactic cosmic rays, high energy particles from across the universe flooded Earth's atmosphere at intensities at least 10 times higher than today. Researchers publishing in scientific reports in 2026 confirmed the radiation spike and found it would have depleted the ozone layer, altered atmospheric chemistry, and triggered a prolonged cooling period. The sun will encounter more interstellar cold clouds. We just have no idea when. Number 3, the Milky Way and Andromeda galaxy collision. In 1912, astronomers noticed Andromeda, our nearest neighboring galaxy, was moving toward us. By 2012, astronomers and scientists believed it was inevitable that a direct head on collision would occur in roughly 4.5 billion years. Two galaxies, each holding hundreds of billions of stars, hitting each other and merging into one. The gravitational chaos would fling stars in every direction, potentially throwing our sun into a completely different orbit. Earth's climate would destabilize and very likely ending civilization. But in June 2025, a team led by theoretical physicist Tilsawala at the University of Helsinki ran 100,000 simulations using Gaia and Hubble telescope data and found that the probability of a direct collision dropped to 50% within 10 billion years. So in roughly half the simulations, the two galaxies fly past each other at close range. It's still a coin flip, but considering there was a time that people believed it was imminent, I'd take these chances. Number 2, hyperbolic interstellar objects. On July 2025, the Atlas telescope in Chile detected a comet moving through our solar system. Within days, astronomers confirmed it was an interstellar comet based off its hyperbolic trajectory, meaning it was moving at speeds unbounded by the sun's gravitation orbit. To put this in perspective, an object just barely escaping the sun's gravity scores a 1, and this thing scored a 6. Scientists named it 3-Eye Atlas, making it only the third confirmed interstellar object ever detected passing through our solar system. What they found very strange was that the composition of it was rich in carbon dioxide and methane, and there were 22 documented anomalies that don't match standard comet behavior. Nobody can fully explain what it was. Although this comet posed no direct threat, it gives us an idea of the potential danger. With detection windows of roughly 5 months before its closest approach, there is not enough time to design, build, or launch any kind of intercept mission, but with the Vera Rubin Observatory now coming online, we will detect many more of these objects in coming years. Some will be larger, some will be faster, and some will have trajectories aimed directly at Earth. Hopefully, the next time we detect one coming our way, we'll have advanced our technology to detect years ahead of time and have the capability to deflect it. Number 1, primordial black holes. Primordial black holes are probably one of the most terrifying things in the universe. It's already bad enough that we don't fully understand black holes, but imagine billions of black holes that are not anchored anywhere. They are constantly moving in any direction. Their size can vary from a tiny pebble to the size of millions of suns. Not only that, but they are invisible to us because they emit no light, and we have zero technology to detect them. A close flyby through our solar system would not look dramatic at first, just orbital mechanics going subtly wrong with no explanation, planets drifting slightly off course, unexplained tidal stresses in Earth's crust, satellite systems failing from gravitational disruption in the upper atmosphere. If one passed through the inner solar system, it could shift Earth's orbit around the sun, triggering drastic climate changes. Even a 1% shift could potentially cause a mini ice age. A 5% change would be catastrophic and very likely ending human civilization. We are literally just a tiny blue ball orbiting a small sun, which is drifting through a universe that likely contains trillions of invisible objects that can destroy us, and it can happen at any time. Thanks for watching. Like and subscribe to see more.